in this lecture we are going to learn about how we do insertion in AVL tree. Okay, so last class we discussed what is an AVL tree and what is the balance property, and we know that okay, AVL tree is a binary search tree in which the left and right subtrees for each nodes are balanced. Okay, so now let's see how we insert. So insertion is very much similar to binary search tree because it is of course a binary search tree, but the only difference is that when you insert a node, so it can cause balancing problem. Okay, so what it means that okay, you insert somewhere, okay, and then the left height of the left subtree minus height of the right subtree, it can become 2, it can become greater than 1. Okay, so that is the problem, and it will at most become 2 because you are only inserting one item at a time. Okay, so that's the case. So after insertion only nodes, now let's see what will happen. So it says after insertion only nodes on the path from inserted node to the root will alter, okay, get altered. So what happens that if there is a binary tree, okay, and so let's say now some insertion happened here, then only the heights of the balancing factor of nodes, this one, okay, so let's do it. So if I inserted here, so only the path from this node to the root, the nodes which fall there, so only for them the balance factor will get disturbed because it is only affecting them. This node is not affecting the balance factor for this. Okay, so it is only affecting the nodes in the path where I am going from that node to the root. Okay, so what happens as we go up towards the root, the deepest node whose balance factor has violated the AVL condition, we note that node and name it gamma. Okay, so we will call it gamma. So when we add this, so because the height of this left subtree has changed now for this node also height of the left subtree has changed, for this node height of the right subtree has changed, and so on, so for the root also. But for this node nothing has changed. Okay, so because left and right subtrees are still not affected by this node, for this node also because of this insertion left and right subtrees are not affected. Okay, so this is the idea, that's why we go from the inserted node towards the root, and only nodes that fall in that path will be affected, their balance factor. Okay, so now let's see the violation at the gamma node now causes various cases. Okay, and here we will see two cases. Okay, so first case is that, let's see, so this is the node. Okay, so in this part, so let us see, this is a generic tree, binary search tree. So here we have k1 as the key, k2 as the key, and this is A is the left subtree of k1, B is the right subtree of k1, and C is the right subtree of k2. Okay, so now what happens is that k2 here, now the balance factor, let's say something was inserted in the end in this A, and now k2 has a balance factor disturbed because now, and initially height of each of these subtree was h. Okay, A height was h, B height was h, C height was h. So now what happened, if it was h initially, so now left subtree total height for k2 left subtree is h plus 1, here it is h, so it is balanced. Okay, but if you add something else here, okay, so what happens, A's height will become h plus 1, and total height of this left subtree of k2 will become h plus 1 plus 1. Okay, so which means it becomes h plus 2, right subtree of k2 is just h, so difference is plus 2, so it is now not balanced, so the AVL tree property is violated. So how will we balance it? So the balancing, and we see this forms, so we are, the node which is violating the balance factor, so we are inserting in the left subtree of its left child. So insert in left subtree of left child of gamma. Okay, so that is happening. So insertion in left subtree of left child of gamma is happening. So this is LL. So to make it balanced, we need LL single rotation will do this. Okay, so what we should do, so if you see, I want to balance this binary search tree. So K2 is the node which is making it non-balanced. So what we do, we make K1 here as the root, because K2 is greater than K1 because of binary search tree property. K1 is left side child of K2. So K1 becomes the root. Then I can have K2 as the right child of K1. Okay. Then what happens if I make this K2 as right child of K1? Where will this subtree B go? Okay. And I know from BST property, everything in B, subtree B is greater than K1. Okay. And K1 is greater than K2. So what will this subtree B can now become the, so it can become what? So K1 is less than K2 and everything in B is less than K2, but everything in B is greater than K1. Okay. So what happens? K1 is the root, K2 becomes its right child, and now everything in B will become the left subtree of K2. This is fine because in B it is greater than K1, so it is falling in the right subtree of K1, and B is less than K2, so it is falling as the left subtree of K2. Now C is there as the right subtree of K2, and also A is there as left subtree of K1. So now if you see, the height of A subtree was h plus 1, height of B and C were both A. So now height of the right subtree of K1 is h plus 1, height of left subtree is h plus of K1 is h plus 1. Now this becomes balanced. So everything now is balanced. K2 is balanced, h and h on left and right. K1 is balanced, h plus 1 left subtree, h plus 1 right subtree. Okay. So this is the LL rotation. Okay. So we are inserting in the left subtree of left side, and if that is causing AVL tree violation, so we will do single rotation, LL single rotation. Okay. So next what happens is the RR single rotation. So what is that? So we are inserting into the right subtree of right child of a unbalanced node. Okay. So K1 here has the problem, it is violating the AVL property, and so this K1 is violating the AVL property, and we see that now we are inserting in the right subtree of its right child. So again A, B and C are all subtrees of height h. So what will happen? When we insert a new node in this, so C will become of height h plus 1. Now if you see, so K2 here is h, left subtree height is h, right subtree height is h plus 1. Here it is minus 1. But at K1, its left subtree has height h, right subtree has height h plus 1, it becomes h plus 2. So there is minus 2 balance factor. So what happens? This is violating, K1 is violating the AVL property. So, and how we do? So this is RR type of AVL tree violation. So what we do? Now we make K2 as the root, C will remain its right subtree. But what happens when we have made K2 as the root? So where will K1 go? So that K1, because K2 is greater than K1, so K1 can now become the left child of K2. So this is done here. Now where will this K2 had already got a left subtree, and everything in this left subtree B will be greater than K1, so I can make it as the right subtree of K1. Okay, and still this is everything in B is less than K2, so it is in the left subtree of K2. So this way, this is the RR rotation. Okay, so in this example, if you see 5, this binary search tree, if I insert 7 here, so initially if 7 was not there, this 8 had a 0, 10 has +1, then 0 has 0, 3 0 balance factor, 4 has +1 balance factor, 2 has got -1 balance factor, and this has got +1 balance factor, the root. Now if we insert 7, so what happens? So let's see. So here this balance factor changes. So now going from this inserted node towards the root, 8 balance factor, now from 0 it becomes +1, for 10 it becomes +2, and here AVL property is violated. Okay, so while going from inserted node towards the root, so 10 violates the AVL property. And if we see, so this insertion has happened in the left subtree of its left child of node 10, which is violating the AVL property, the gamma node. So what we do, we will do LL rotation. So now what happens, 8 will become, so we see 8 becomes the root of that subtree, 7 will be the left of it, 10 will be on the right, 8 will be connected to 5, and this is the RR rotation example. So now we will just have a kind of dry run. We have elements 3, 2, 1, 4, 5, 6 and 7. We want to insert this and we want to make an AVL tree out of it. Okay, first we insert 3, it is just a single node, so it will be 3, it is fine, it has balance factor of 0, this is fine. We insert a 2 now, 2 is less than 3, it will become left child of 3. Again balance factor is fine, 2 has balance factor of 0, 3 has balance factor of +1. This is good. Now when we insert a 1, it goes towards the left of 2. Now 3 has a balance factor of +2, which is violating AVL property. Okay, and when we see the inserted element is, and 3 is gamma, the node that is violating AVL property, so it is inserted in left subtree of the left child of 3, LL rotation. So now 2 becomes the root, 1 goes to its left and 3 goes to its right. So this is the, after our LL rotation, this becomes the balance tree again, AVL tree. Now we insert 4. So 4 is inserted here and we see that the balance factors are below mod of 1. So this is fine. Now we insert 5. So what will happen, it will come here, and while going up we are again calculating balance factor. For 4 it is -1, for 2, for 3 it becomes -2. So again balance factor is getting violated, and while moving from inserted element towards the root, 3 is the first element or the deepest element, which is violating the AVL tree property. Now 5 was inserted in the right subtree of the right child of 3 or the gamma node. So what we do, this is RR rotation will help us solve this problem. So what we do, so 4 will become the root, or we will consider this part, and let's see. So 4 becomes the root, 3 goes towards its left and 5 remains like this. Now 4 is connected to 2 and 1, so this RR rotation makes it again balanced. Now what happens after this one, so 6 is inserted, So when 6 is inserted, what happens? Again, while going from this inserted node towards the root, with 5 it is find minus 1 balance factor, 4 it is find minus 1 balance factor, with root 2 it's now minus 2 balance factor. So what happens? 6 is inserted in the right subtree of right child of 2, RR rotation, and RR rotation will come at 4, 4 becomes the root, 5, 6 comes here, 2 will become its left child, 1 will be there, and 3, the left child of 4, will become the right child of 2. So this is fine. This is the RR rotation, and now we could see that the LL and RR type of insertions can be handled by single rotation